I'm going to show you the Oxford SuprEsser plugin, which is a fully featured professional de-esser plugin, and actually a whole lot more besides. As you can see, it has a very intuitive graphical interface, which gives a lot of visual feedback, which makes de-essing very easy and quick, because you can see exactly what's going on. You can literally just grab your sliders, find the area that you want to de-ess, grab your threshold. It's very, very quick, intuitive and simple. Or you can, of course, get into more fine tweaking with some of the other controls. For example, you can adjust the width of the band, you can move it around, you can adjust the slope of the filter, or your Q, which is represented by this red triangle here. If I make it a lot steeper, you'll see the triangle get a lot sharper. It goes up in 12 dB increments, up to 72 dBs per octave. You have 3 different listen modes. Mix, which is obviously your input plus your de-essed signal combined. You can listen to only what's inside this band, so you're only going to be de-essing what's inside here, and you're listening to only this problem frequency. Outside will allow you to listen to what's outside this band, so you can check that you have indeed got the right frequency band here, and everything else here is what you want to keep intact. And then you can go back and check and listen to the entire mix. You've got a lot of feedback here. This red bar, for example, this spike will give you the peak frequency within this band, so that's going to be the most obtrusive frequency within the band that we're interested in here. One other thing to note is this little tool here, this magnifying glass. I can zoom in or zoom right out, and as you can see here, we're looking at the entire spectrum from 20 Hz all the way up to 20 kilohertz. So really useful for taking all kinds of unwanted frequencies out, whether it's low-end thumps and kicks or plosives to sort of high-end frequencies. So it can be used as a lot more than just a de-esser. I'm actually just interested in de-essing a vocal right now, so we'll go back to there and we'll actually zoom in a little bit to get a better resolution of what's going on. So let's have a listen to it now. I will unmute the vocal. Cast a spell with cinnamon. So this is where I've taken the effect out. Home from school. You can hear that sibilance. I missed your mom, but it was cool. S's are a little bit over the top there. So obviously we want to take them out dynamically, as opposed to applying an EQ where we cut by the same amount of frequency all the time. We don't want to affect the rest of the vocal. We only want to apply de-essing to the S's specifically when they come up. We don't want to touch the rest of the signal that's left untouched. So it's a dynamic EQ essentially. So let's switch it in. Let's just play that loop again. I'll play the first bit without. The kindergartner's home from school. I missed your mom, but it was cool. Now I'll switch it in. The S's will sound a lot more natural. The kindergartner's home from school. You can see it de-essing here. I missed your mom, but it was cool, and I learned how to write. Let's do that again. The kindergartner's home from school. I missed your mom, but it was cool. And in. The kindergartner's home from school. I missed your mom, but it was cool. I haven't overdone it. You can really, really overcook it, and you'll sound really silly, and the S's will be totally overdone. But the S's are there, but they're not too de-essed, and they're not jumping out at me and making my eyes water. Now, as I said before, the suppressor will operate full band across the entire spectrum. So if you want to do more than just simply de-ess and take out other problem frequencies, for example, here I've got a low-end thump. I don't know whether they singer kicked the mic stand or what happened, but there's a nasty low-end thump that we want to remove, but leave the rest of the voice intact, of course. So we're going to concentrate on an area quite low down here. We can zoom in a little bit more on that area. We've got from 20 Hz up to about 232. So let's play the audio without the suppressor in, and just listen out for that thump. It's just on the word faithful. Faithful friends who are dear to us. You hear that? Faithful friends who are dear to us. Faithful friends. Okay, now I'm going to switch it in, and you'll actually visually see it. Faithful friends who are dear to us. It's quite visible that there's a couple of very large thumps here that have just been taken out. But the rest of the voice is completely intact. Take it out. There's that really low sub kind of thump. And now with it back in. So the voice is exactly the same, it's just that the thump's gone. So we've got this access button here, which opens up a whole bunch of extra controls. As you can see, the suppressor really comes into its own here. It becomes a lot more than just a regular de-esser. It's more of a dynamic EQ. You've got real control. So it's really quite powerful. For example, mode here, this determines what's going to trigger the compression, which is set by this frequency band here. Wide will have full band, the entire spectrum. Any of that signal will trigger the compression. And then the audio, this decides what's going to get compressed. So with band in, only this is going to get compressed. With wide, the whole signal is going to get compressed. So for example, with wide, this is the behavior of a regular compressor. The entire spectrum will trigger full band compression. You could just get these frequencies only triggering the whole spectrum. For de-essing, I like to have it band so that these frequencies will only be triggered and compressed, and we leave the body of the audio alone. Level tracking is kind of interesting. I'm just going to mute the vocal. And you'll see this threshold is actually kind of floating up and down because we have this auto level tracking in. So if I switch that out, you'll see that it's absolutely fixed. I can put it up or down. Why it's useful to have auto level tracking is, for example, a vocalist might get kind of excited in the chorus, might be singing a couple of dBs louder than in the verse, for example. And in that case, if this was fixed, because their singing level is going to be slightly higher, you're going to get that much more compression because they're going to be going over the threshold more. You're going to get more de-essing in the chorus than you would in the verse. We don't necessarily want that. We want the same amount of de-essing applied, a few dBs, in the verse and the chorus. So what level tracking will do is it will look at the average level of the voice, and it will apply the same amount of attenuation throughout the whole song, depending on what we've set with our threshold, but it will give a good average level of de-essing throughout the song. You've got your reaction envelope, so your attack, hold, release. You've got a ratio even, so gentle compression, heavy compression, complete removal, really extreme compression. You've got a make-up gain, as you'd expect to find on a compressor. You've even got a variable soft knee in 5 dB increments, as you'll also find on the Oxford Dynamics plugin. You have wet-dry control, trim, output, so you can trim your output and just take that down a little bit. So really quite a comprehensive set of controls on the Oxford suppressor, making it a very powerful dynamic EQ. So to recap, the Oxford suppressor is a linear phase dynamic EQ and de-esser. It transparently controls aggressive frequencies, has a large graphic display for increased accuracy, 3 different listen modes, automatic level tracking, full spectrum operation from 20 Hz to 20 kHz, and an advanced mode for ultimate control.